everyone. Hi there. My name is Anthony Sequeira, an AWS certified solutions architect and consultant, and I'd like to welcome you to my Amazon Redshift Best Practices course here at Pluralsight. In this module, we're going to learn to design and deploy AWS Redshift. As you probably know, AWS Redshift is one of the fastest growing AWS services offered by Amazon. This is because it is an incredibly scalable, very great performance, robust, highly available data warehousing solution in the cloud. In this module, we're going to begin by taking a look at the overall AWS Redshift architecture. It's important that we understand the architecture so that we can better manage and maintain it and use best practices to get the most performance and also to secure the Redshift infrastructure. We'll also look at actually deploying AWS Redshift. So what are the methods of deployment and what key, again, best practices can we use to make sure our deployment is successful? We'll then discuss the management of the Redshift clusters that make up the AWS Redshift solution, and we'll talk about how you can easily design test environments and how to do this cost effectively and also in the lowest time possible. And to that end, we'll also discuss in this module the importance of automating Redshift and the various automation capabilities that exist within and even outside of AWS Redshift itself. All of this is very interesting to our organization that we'll focus on as we move throughout this module and others of this course, and that is the wonderful IT department folks specializing in both data storage, data analytics, and also just databases in general for the organization of CarveRock Fitness. More and more, it is being discovered that there are massive quantities of very valuable data inside of CarveRock Fitness, and more, there's been this push to start data warehousing for these massive data stores that CarveRock Fitness is starting to accumulate, and unfortunately not really taking advantage of. So we'll follow along as CarveRock Fitness takes advantage of AWS Redshift and all the wonderful advantages that they'll achieve in doing so. As promised, let's take a look at the AWS Redshift architecture. It really is an interesting architecture, and there are some surprises. Now, before we get too deep into the architecture itself, let's just review a couple of the overall principles of AWS Redshift. The AWS Redshift service found its life in 2012, and it was a massive success for Amazon. In fact, Redshift quickly became one of their fastest growing services. And this is directly a result of the fact that there's more data than ever that organizations want to store. Take our example of CarveRock Fitness. Initially, they were interested in storing data on their various outdoor products, and they were interested in storing data on their customers, and they were interested in storing data on sales transactions. But then when they had a larger than ever online presence, when they started an online community, when they started branching out into health clubs, and when they even started having the Internet of Things devices all over factories and health clubs and warehouses, then they realized, my goodness, we want to do analytics against this data, and we need help with the storage of all of this data. And keep in mind that the data is often in many different forms. AWS Redshift, as so many of the services are at Amazon, it's fully managed. So we love that here at CarveRock Fitness, because we're not going to have to deal with the administrative overhead, and it's substantial, that would be involved with maintaining a data warehouse ourselves on-prem. It can scale incredibly. As you're going to see, the AWS Redshift is a cluster of compute nodes inside of AWS, and we can scale it up to 128 cluster nodes. This gives petabytes of data the ability to be stored here and analyzed. And of course, along with all of the key services of AWS, this Redshift tightly integrates with many other services. When we are tossing data up to the cloud for AWS Redshift to store, we can toss that data into an S3 bucket, for example. And then S3 can very, very efficiently move that data into Redshift. And we know it's actually the other way around, right? Redshift will reach out to the S3 service and it will pull that data in. Now, AWS Redshift is really, really celebrated for how high performance it can be. Now, while this is a very performant platform, just keep in mind that that's not automatic. We need to know what we're doing as far as best practices go to get the very best performance out of it. Remember that AWS Redshift is not, I repeat, it is not designed for online transaction processing. No, we would use something like AWS RDS for our transactions that we are having the database take care of. This is designed for the analytics, right? So we're going to be doing the analytics processing and the business intelligence type manipulation of the data that's in AWS Redshift. This is, as you know, a growing field as we can glean very valuable business information by looking at all of this wonderful data. It's ANSI SQL compatible, so that's great news for those of us that cut our teeth on SQL as we were learning database technologies. And finally, instead of storing and processing and working in rows, as is typical in like an online transaction processing system, this is column-oriented. We'll be talking a lot about that in this course, but it's very important to realize, yeah, everything's in terms of columns, not rows. Now, when we look at the AWS Redshift architecture, the first big surprise for many is that we are talking about something that is constrained to a single availability zone. So right away you might go, well, wait a minute here. What about high availability? With high availability designs, we like to leverage multiple availability zones. But in this case, we do not do that. And that is because we have a cluster, and the cluster needs to be guaranteed high bandwidth connectivity between all the nodes, so everything stays within an availability zone. And something else that's worth pointing out about this is the fact that, remember, this is for data analytics, so by its very nature, it's not going to really typically need the same level of availability that we would have with like a transaction processing system. Well, when it comes to the cluster itself, it is made up of an important compute node that's called the leader node. Take me to your leader, we could say in Redshift. The leader node is where we would make connections like with our ODBC connector, or maybe we're connecting in with a SQL connection, and we connect to the leader node, which then runs queries and does processing in parallel against multiple compute nodes. That's the big deal here when it comes to the robust performance that we can get. In fact, many like to refer to Redshift as an MPP style database. That stands for massively parallel processing, and that is a great thing in the world of data warehousing. We love that we can process these tasks in parallel. And notice from this architecture too that we can easily scale. So as we are getting more intense with the amount of information that we're storing in Redshift, and as we're getting more intense with the types of analytics that we want to do, we can scale the compute nodes out by adding more of them, or scale them in if we have to by reducing them, and we can also scale them up or down. So we can make larger compute nodes or smaller compute nodes. So lots of options there, and we'll be discussing this as part of our overall best practices. So the architecture and the selling points of Redshift, they are legitimately exciting, and it's important for us to review this information, obviously, before we move forward. Just like with any AWS service, we really want to practice with the deployment of the technology. And I find with sophisticated solutions like AWS Redshift, students often don't do this. And I know one of the concerns is probably price, but if we're very careful to use AWS Redshift for a short period of time and then shut things down or even terminate things, it's not going to be a huge expense. And take it from me, should you forget to shut things down and leave them running and then get a massive bill from AWS, they'll be great when you call them and explain the situation. Yeah, they're really, really great about credits. And in fact, I've had it happen more than once where they've taken that as an opportunity to look at all of the services that I've configured and tell me other things that clearly I was demonstrating for students and inadvertently left running. Now, as part of this,
Marco.
Let's see. How about an M5X large? Okay, so we're talking about 4 CPU cores and 16 gigs of RAM. We are choosing something like this because we want the data generation to go quickly. Remember, we're going to have this node generate 40 gigs of data to load into Redshift. So we want that process to go fast, and then we're terminating this thing, right? So we should actually save ourselves money by using a beefier machine. It'll be done a lot quicker with the data generation, and then we can delete the machine. So I'm going to go to instance details next, and I'll just put this in my default VPC in any available subnet. It's going to auto-assign the public IP. That's great. Here is a key step. We want to go and grab that role underscore data gen that we created and associate it with the EC2 instance there. Other than that, we're ready to go to the storage step, and we're going to add a nice 100 gig SSD. Why so much space? Well, remember, we're going to be generating that 40 gig of data. I'm going to go ahead and add a name tag, of course, and this system will be EC2 underscore data gen. And then our security group, we will create a new security group. I'll say SG underscore data gen. It allows SSH, of course. This is Linux after all. And I'm going to leave it open to the world. We're not going to be using the EC2 instance for long, that's for sure. And we're going to launch this thing, and I'm going to specify it's the KP underscore Redshift, and I'm going to acknowledge that I really do have access to that key pair information. And there we go. We can go ahead and just go back to the EC2 dashboard now, and we can see that our instance is running, and this very important system right here is going to be the system that we use to generate no less than 40 gigs of data that we can work with inside of Redshift. In the next video, we're going to go ahead and access this data generator and actually do the data generation, and I hope to see you there. In the previous video, we went ahead and created an EC2 instance that we were going to use to generate plenty of data for Redshift utilization. And let's go ahead and get that done now. So we're at this EC2 instance. I'm going to choose connect. And notice that I can just copy this string here for my SSH connection. So I'm going to copy that and then bring up the dark place, as we used to call it, inside of Windows, the command prompt. And here we're going to go ahead and just paste in that SSH string. Actually, you'll want to make sure you're in the directory where your key is, though. So let's go and do that. So I'm going to do a change directory into OneDrive. And then, yep, it's AWS underscore keys. And you can use tab autocomplete, believe it or not, in Windows to help get that done. All right, now we're going to paste in our SSH string, and we're going to say, yes, we want to continue to connect to this instance. And now we're going to go ahead and get the data generation handled. We're going to be calling upon the great work of the tpc.org. There's the TPCH benchmark. This is a great tool set for data set generation and for doing analysis of the performance, benchmark performance of database technologies. So those good folks up there give us great freeware tools that we can utilize. All right, so here's what I'm going to do. I'm going to be doing this from Git, surprise, surprise. So we're going to do a sudo yum, and we're going to install make git. And this is our first step. We're going to say, yes, we want to go ahead and complete this installation. Then we're going to go ahead and do the clone of the appropriate Git. So I'm going to do git clone, and it's going to be HTTPS, and it is github.com/Greg Ron. If you have a chance, go check out his profile. Impressive individual, and I love his tagline. He was into big data before it was big, or something like that. It's great. And then TPCH-hit. All right, excellent. So there is the GitHub clone that we're going to do. So we have those resources here on this system. The next thing we're going to do is install some compiling tools. So sudo yum install gcc. each of the incrementing files. So let me hit enter, and it will go to work splitting those entries. Let me do an ls, and there we go. We've got our orders tables now that are split. Let's do the same thing for the line item. Here we had a lot of records, 16 million. So let me issue the split command again, and we'll go in and say, oh, how about, let's see, 16 million. So, boy, I'm terrible at math. We know that to be true. Let's do 4 million for the split here. And we're going to, of course, doctor up this name right here. So this is going to be the line item. If I can type that correctly. There we go. And then this is line item right here. All right. And that looks good, and that has executed. Let's do an ls again. Yes, that worked beautifully. Now we can remove the originals. So we're going to do line item.tbl, and then I'm going to remove the orders.tbl. There we go. So now in that directory, we just have our split database raw data that we can utilize in Redshift deployments when we are testing and, initially validating designs. So this is great. Well, in the next video, we're going to go ahead and we're going to copy these items up to an S3 bucket, and that's a perfect place for us to have this raw data so we can work with it in Redshift. In the next video, we'll also get rid of, goodbye, to this data generation machine that we no longer need. It's served its purpose well. As you might guess, copying the data from our EC2 instance to S3 is going to be simple. Let me start by creating